Time in history, a man-made object has left our solar system. NASA is saying the Voyager 2 probe.
Voyager 2, launched in 1977, has long been a symbol of human curiosity, endurance, and scientific tenacity. As the spacecraft drifts in the deep and distant reaches of space, more than 12 billion miles from Earth, its latest encounter has stirred astonishment within the scientific community. Against all expectations and models, Voyager 2 has made what researchers are calling an impossible encounter at the very edge of our solar system. An interaction that challenges existing theories of the heliosphere, interstellar space, and the invisible boundary that separates our star's domain from the vastness beyond. Before we start, smash the like and subscribe buttons for more updates. The outer edge of the solar system is not a hard shell but a transition zone, a region where the solar wind, a stream of charged particles flowing outward from the sun, slows down and meets the interstellar medium. This area, known as the heliopause, is the boundary where the pressure from the solar wind is balanced by the pressure of particles from interstellar space. Voyager 2 crossed the heliopause in November 2018, entering what was believed to be interstellar space. But in its continued journey, the spacecraft has now transmitted data from a region that defies our current understanding of that boundary. This unexpected encounter occurred in a zone previously thought to be relatively calm. Instead, Voyager 2 detected sharp increases in cosmic ray activity, sudden reversals in magnetic field direction, and dense, compressed plasma unlike anything predicted. The magnetic field lines, which should have shown a consistent direction aligned with interstellar patterns, were instead twisted and coiled into shapes that resembled vast knots. These readings, collected by the spacecraft's aging yet functional instruments, revealed that something dynamic and powerful is happening just beyond what we had defined as the border of the sun's influence. One of the most astonishing aspects of this event is the behavior of the plasma environment. The readings indicated a region of space that is not passive, but highly structured and reactive. The plasma density, far from being a uniform haze, was discovered to be fluctuating dramatically over short distances. These observations suggest that the edge of the solar system is far more turbulent and layered than previously imagined. The interstellar medium, it seems, may be interacting with the solar bubble in ways that produce ripple effects and disturbances that travel back into the heliosphere, causing shifts that Voyager 2 is only now recording. What makes this encounter impossible is that no existing models had predicted such a zone. Scientists had long believed that after crossing the heliopause, the interstellar medium would exert a relatively steady and uniform influence. But Voyager 2 has found that the interaction is not linear, nor is it stable. Instead, the spacecraft has drifted into a kind of cosmic buffer zone, an interface region where the forces of the sun and the galaxy collide in a swirling, churning mix of magnetic fields and energetic particles. The implications of this are profound. For decades, models of the heliosphere have depicted it as a kind of comet-shaped bubble with a smooth boundary at the heliopause. Voyager 2's data challenges that vision. The evidence now suggests that the heliopause may be more like a porous membrane or a constantly shifting shell, susceptible to the pressures and currents of the interstellar medium. This dynamic boundary may expand and contract in response to both solar cycles and galactic conditions. It might even contain corridors or filaments through which particles and fields can travel in both directions, suggesting a far more interactive boundary than previously supposed. Additionally, the strange magnetic reversals observed by Voyager 2 hint at the presence of interstellar magnetic reconnection events, phenomena where magnetic field lines from different domains break and reconnect, releasing vast amounts of energy. These events are well documented near Earth, especially in the magnetosphere, but their presence at the outermost limits of the sun's influence was not anticipated. The fact that Voyager 2 detected them implies that the edge of the heliosphere might be a far more active and energized environment than anyone imagined. This raises a host of new questions. What causes the magnetic field to twist so dramatically in these regions? Could the heliosphere itself act like a dynamo, influencing the shape and behavior of the interstellar magnetic field? Might there be feedback loops that stretch back into the solar system, affecting cosmic ray influx, solar wind structure, or even climate conditions on Earth? While definitive answers remain elusive, Voyager 2's data has opened the door to lines of inquiry that were previously closed or not even conceived. Perhaps most intriguingly, this encounter suggests that the edge of the solar system is not a border, but a frontier. The difference is not merely semantic. A border implies separation, a clear division between domains. A frontier, by contrast, is a space of blending, of exploration, of ongoing conflict and cooperation between forces. What Voyager 2 has uncovered points toward a dynamic interface that may change over time, respond to solar activity, and shape the interstellar medium in its own right. Moreover, these findings force us to reconsider how the Sun interacts with its galactic neighborhood. If the solar system is not a sealed bubble but a breathing, shifting presence within the galaxy, then our understanding of cosmic shielding, radiation exposure, and even the movement of interstellar particles must be revised. For example, the cosmic rays that bombard the Earth, and which are partially deflected by the heliosphere, may have a more complicated journey than we thought. The nature of their interaction with the heliospheric boundary could affect not only spacecraft and astronauts, but also the planet's long-term atmospheric chemistry. The spacecraft's slow drift through this strange region continues to yield surprises. While its instruments are limited by their age and power supply, the clarity of the data they still transmit is a testament to both the engineering marvel of Voyager and the unexpected complexity of the cosmos. Each byte of information sent across the abyss of space is a challenge to what we thought we knew about the boundary of the solar system. Voyager 2's impossible encounter is also a reminder that the frontier of space is not just out there. It is active, responsive, and filled with structures and phenomena we have yet to comprehend. It is not the passive, static void once imagined, but a dynamic arena where forces clash, intermingle, and evolve. In some ways, the region Voyager 2 now explores may be more alien than anything it passed during its planetary flybys. The gas giants, the Kuiper belt, and the heliosheath were within the influence of the Sun. Now, for the first time, a human-made object is feeling the direct touch of the galaxy itself. Even more fascinating is what this tells us about the larger galactic environment. If our solar system's boundary is this complex, what does that mean for other star systems? Are their own protective bubbles similarly dynamic? Could the nature of these boundaries influence the evolution of planetary systems, the survival of atmospheres, or even the development of life? If magnetic reconnection and turbulent plasma environments are common at heliopauses across the galaxy, then these features may play an important and previously unrecognized role in cosmic evolution. Furthermore, the data suggests that the interstellar medium itself is not as uniform as once believed. Voyager 2 has found patches of higher density, suggesting that space between stars may be more like an ocean with currents, eddies, and pressure systems. The spacecraft's impossible encounter may have been with one of these features, a kind of cosmic weather front, crashing into the outer solar system and altering its outer structure. If this is true, then mapping the local interstellar medium may be as important as mapping the stars themselves. These unseen pressures and fields may influence how solar systems form, evolve, and ultimately fade. The technological achievement of Voyager 2 is staggering, but it is its scientific legacy that continues to grow. By encountering a region that defied predictions, the spacecraft has humbled and inspired the scientific community. The encounter underscores the limitations of even our most refined models when confronted by the scale and variability of the cosmos. It forces a reassessment of what it means to explore. Not every discovery comes with a headline or a perfect image. Some come as bursts of data that reframe decades of assumptions. There's also a philosophical depth to this moment. For all the sophistication of our instruments and the power of our theories, nature still holds the capacity to astonish. In an era of high-precision science, Voyager 2 reminds us that exploration still involves mystery. It is a return to the roots of curiosity, not knowing what lies ahead, but pressing forward anyway. The spacecraft's journey is more than just a scientific mission. It is a continuation of the oldest human instinct, to reach beyond, to look outward, to find meaning in the unknown. As Voyager 2 continues to coast into interstellar space, the region it has just passed through may become a focus of intense study for years to come. Its impossible encounter has already led to a flurry of new simulations, theories, and proposals for future missions. What lies ahead remains unknown. But if this encounter has proven anything, it is that the edge of the solar system is not a place where exploration ends. It is where it truly begins. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Voyager 2's mysterious signal near the heliopause? We want to hear from you. Thank you for watching and see you next time.